like how the product, how that uh, the thing behaves.
Mm-hmm. Yeah, just feel free to talk. I mean, whatever you feel. At this 1 year only you're going to study, so I mean, enjoy your student life. Yeah, yeah. Please go ahead.
So the structure property relationship is like the the structure of the product and how it's going to react.
No, no, it's not that. Anand, do you know something about that? Structure property relationship.
So I think like depending on the microstructure, there is some correlation between microstructure and like property.
Exactly. It can be of microstructure or macrostructure or structure of the material. Say, for example, you have iron carbon diagram. So the moment when you increase in the carbon content, you get increases in the modulus and tensile strength, etc. As a result, I mean, on the other hand, you're gonna, I mean, your elongation will be sacrificed. So this is how, I mean, by looking at the chemical composition or the polymeric structure, so you're gonna, have some rough idea about those, properties of those compound or the materials. So that's what I mean. That explains. That is called like structure property relationships. Okay. Okay. So that also you're going to study. So what are the different structure and their property and different functional materials, etc. And I'll give you some touch upon nanotechnology as well, like what is nanocomposite and nanomaterials and their different synthesis method and how to fine tune their morphology of nanomaterial and its impact in the preparation of nanocomposite. And at the end, we'll study the significance of nanocomposite and its comparisons with the microcomposite and macrocomposite. And then, yeah, we'll see a lot of real-time applications like how exactly the smart materials or the functional material or the engineering materials are used in different applications like automobile, biomedical sectors, etc. Okay. So yeah, although I've given some of the books, I do not really follow, single books. I mean, on top of that, I'll be referring different articles. Of course, I'll give you the time to time, I'll give you the reference, DOI number or the, link where to access the papers. Okay. So of course, yeah, the basics you can get it from here. Okay. So if you need any kind of ebooks, you can get it from any kind of, website. There are a lot of websites where you can download. Still, if you don't get, let me know. Okay. So yeah. So this is how your syllabus or the course content. I'll start with the basics of materials and technology, and then we will straight away we'll get into composite materials. Okay, and then yeah, we'll see different mechanics of composite and the dispersion strengthening, etc. And then yeah, we will study different types of composite. That means we have different matrix, right? Polymer based matrix, metal based, and ceramics based matrix. Okay. And in that, what is functional material or the advanced engineering materials? And then yeah, we'll start quickly nanotechnology, why it is so and why it is so important in almost all the fields. And then we'll see different fabrication methods for nanocomposite. And then we'll study the differences between nanocomposite and other types of composites. And then yeah, we'll get into the metal-based, smart materials or the engineering materials. Like what are the materials being used in high temperature services, etc. And their fabrication process and their properties, etc. Okay. So again, the third model like will concentrate on only the special steel and then other trip steels, etc. Okay, fine. So this two picture will give you the broad idea of like why to study and what is the necessity to study about the engineering or the materials engineering and why should you care about this. And yeah, so if you see the reverse engineering, why the failure was happened, it's because of lack of engineering concept and lack of of course materials engineering concept, and of course the design, etc. So one should consider all this aspect. The design as well as the materials as well as the mechanical aspect. All these things have to be considered if you want to make the successful product. Any kind of product. Okay. And when it comes to the extreme special applications, say for example, this kind of, aircraft, you cannot sacrifice, anything. You have to be really, careful. The in terms of selection of material or the mechanical concept, all these things. Okay. So roughly the material science, what we have been studying is that we deals with the basics knowledge about the internal structure and their properties and the processing of materials. Okay. So if we see the, the flow chart, like how exactly it works. Okay. So you know the basics knowledge of the materials, and then of course you'll be knowing the properties, etc. Okay. And to get these properties, you'll be applying some of the knowledges. I mean, in the sense you will be processing the materials at different temperatures to have certain type of macrostructure. Because if you get so and so macrostructure, then only you get so and so properties. So with the combination of all these things, you're going to achieve those, desired properties as well as the structure and the concerned applications where it matches those properties. Okay. So that's what processing, and then after processing, you're gonna get the desired structure, and once you get the desired structure, of course, the properties will also be there. Once the properties there, then it can be, applicable to, any kind of, targeted areas which has excellent performances. So again, this is kind of again the same explanation, like fundamental principles of material science and engineering, like structure, processing, and properties are kind of correlated, intercorrelated. Okay, so what should I say? Metals, okay, and we have a different fabrication methods. You can do solution casting, or you can do melt casting, or stir casting, or surface coating, etc. But yeah, you have to select particular method for the desired product where you are going to, apply your, where you are targeting the applications. It's not that straight away you're going to do the melt casting or the stir casting, and then you're going to use it for some sort of like a very high performance application. No, it's not. It's not that advisable. So it has got a lot of defect in the processing. So all these things you have to be very careful, and you should consider really. So that's what you have to consider, although we have a different processing technique, casting, forging, stamping, and layer by layer technology, etc. So really you need to see which process is fit for your product or the applications. Once you fix the processing, then that takes you to the exact properties of the structure would you like to have it. Okay, of course, before getting there, there are a lot of characterizations tools you have to use to have idea about those structure or the defect or the microstructures, etc. Okay, of course, you might have studied now, you have studied all those things like transmission electron microscopy, SEM, and X-ray, and X spectroscopic, etc. Okay, all right. So if we see the basic material, whatever we have so far, like these are the three major materials. One is metals and polymers, and then ceramics. And three of them have different distinct characteristics. Like the polymer has got excellent elasticity, and ceramics has got excellent modulus, and metal has kind of, significant amount of hardness, the modulus as well as the elasticity. Okay. And yeah, if you see the, the other properties, of course, polymer has got excellent, biocompatibility compared to that of materials and ceramics. Yeah, of course, polymer has got some disadvantage, like kind of degradation issue, etc. So all those things you have studied. So coming back to again the metallic materials. So if you see the major metallic elements like iron, carbon, aluminum, yeah, of course the major content is iron. Yeah, and the copper is maybe of very a small quantity of copper, and maybe of other elements like aluminum, etc. And that depends on the alloys, etc. So yeah, so if you see the properties, like since they have got excellent crystalline structure, they could give very good mechanical properties like modulus. And it has also been used in the thermal and electrical conductivity purposes, etc. Again, metals and alloys hardly roughly classified into two major subdivisions, like a ferrous and non-ferrous. Ferrous kind of steel and cast iron, and then maybe a few amount of copper, etc. To have those kind of special properties, kind of improving their corrosion resistance. And the non-ferrous, of course, it's there is no kind of iron content, like a combination of copper, aluminum, zinc, etc. So all these things you might have studied in your other courses, steel processing, etc. So these are the few grades of steel. Like I mean, 10. It starts with the 4 digit, and the first, I mean, 2 digit give you the alloy content. Like either it is belongs to the iron or nickel, etc. And the last 2 digit, I mean, second 2 digit gives you the percentage carbon content. Okay. So what I was telling in the beginning of this class, I mean, 2, 3 slides before, like processing is very important. Here you can see here the same, I mean, kind of, I mean, different types of steel, I mean, grades having different properties. Okay, I mean, the standards. In the next slides, you will see that the same kind of steel, like 1040, which was fabricated by using different processing temperature or the processing techniques, like which was hot rolled and then it was cooled at, I mean, normalized cooling method. Then you can see the tensile strength, which has got 86 kgs. And the same 1040 steel, which was constant tempered at different temperature, and then you could see the different I mean, properties. So you know why is it so? Logit? Hello, Logit? And last 1 year we are this virtual mode, right? I've seen guys that whenever we ask question, they'll be saying that we have internet issue. I think Logit is also going to say the same thing. Hello, Logit? Hmm, who was here? Prakriti? Hello? Start to interact, otherwise the class will be very boring. I mean, since this is virtual mode, like I feel like sometimes I'm talking to the laptop, so if you don't talk, like, yeah, it's going to be very boring for you also and for me also. Fine. And yeah, so what I'm telling, that the processing method of processing technique is very important to have those desired properties. Okay. Again, when it comes to the ceramic materials, they are I mean, kind of chemically bonded together like metallic and non-metallic elements, and they are inorganic, but can be either of crystalline or non-crystalline, mixture of both. I mean, structure like crystalline or non-crystalline structure. It has got excellent hardness and strength and wear resistance, etc. And it has got excellent insulating characteristics. That's the reason it has been used in the furnace, liners, etc. Okay. Coming to the polymeric material, and yeah, you have studied in the third semester. It's a combination of like many single monomer units are combined and it forms a very macromolecules. So it looks like organic gained molecules, which is mostly of non-crystalline. That means completely amorphous. Some are mixed, some of the polymers is a mixture of crystalline and non-crystalline. That's the reason those polymers are called as a semi-crystalline polymer, and it has got very poor conductors of electricity. That's the reason it has been used for the insulating purposes. Okay, and yeah, strength wise, yeah, it is not that great, yeah, but ductility, that means it has got excellent elasticity or the laminations. Okay. In the polymeric materials, we have a different divisions, like subdivisions: natural based polymeric material and synthetic material. Synthetic material, of course, we have again categories like thermoplastics and thermosets. I hope all those terms are familiar. Okay. I mean, very short, like thermoplastics or non-degradable, sorry, non-recyclable, and thermoplastic is recyclable. Time. Okay. So I am stopping here. What I used to do, I usually take 20 to 25 minutes and 5 minutes interactions. So you can start to interact if you have any kind of questions. I mean, as of now, we have not seen anything. Yeah, still, if you have anything, we can discuss now. If you have no questions, right? Okay, then we'll see you on Thursday, right? Our next class. Mm, yep. Thursday 2 o'clock, same time. So time to time read. I mean, you must be having a lot of
Quiz
time.
format.
Sorry, Gupta, what are you asking?
What will be the quiz format?
It could be of anything. Like you'll be understanding after like couple of classes, maybe of 10 hours classes. So like I'll be discussing some of the scientific research article. Now you're in the 4th year, so you must be now very well versed with the scientific article, how to read, etc. So I'll be sending you some of the scientific articles, and I'll be asking you some of the questions. It's not that only quiz like objective types, etc. Of course, there'll be some objective types. Yeah. But not to panic. It's nothing. Okay. Because if I ask the general things, no, it's going to be very hectic for me. Everybody will copy, and that I'll be confused actually to whom they have copied, or I have to do the reverse engineering to everyone. So that will be confusing for me and hard work headache. Fine, that is not the big thing to talk now. Okay, Gupta.
Yes, sir.
Okay, okay. See you then. This
So
Thursday.
also in this course, we will be mainly focusing on composites, right?
No, 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 not at all. But if it's why I am talking more about composite here, if you see the real-time applications, you take any applications, it should be, or supposed to be of kind of some composite based combinations. So none of the product has only the pure metal or a pure alloy or pure ceramics or polymers. They'll be adding some fillers to strengthen the matrix, okay, as well as to reduce the cost. Anything else, Gupta?
No, sir.
Yeah, I hope you're gonna enjoy. We'll bring a lot of real-time applications, and then I'll connect them with the what people are doing in the current research trend, etc. So I hope if you are good in that area, like not good, if you're interested, so you're gonna be enjoyable. Okay. Okay. See you then, guys.
So, excuse me, sir.
Okay. Yeah.